Okay, let's take a look at problem 5, applying combined variation. So in physics, when you take physics one day, or if you're already taking it, gravitational potential energy, PE, is a measure of energy. PE varies directly with an object's mass, m, and its height, h, in meters above the ground. Physicists use g to represent the constant of variation, which is gravity. The skateboarder in the photo has a mass of 58 grams and a potential energy of 2273.6 joules. What is the gravitational potential energy of the 65 kilogram skateboarder on the half pipe? So we're going to write the formula for potential energy, and it is G. G is the K that we normally would use. So it was G times M times H. So G is the constant. And we're going to find that constant. And this constant holds true for potential energy always, but we're going to find it for this equation. And we are given the mass and the height. And we're given the potential energy. So they solved for G, which is fine. You don't necessarily have to do that. They did, so they divided both sides by MH, and they got potential energy equals MH. Then they substituted in their values, so potential energy was 2273.6 joules. The mass was 58 grams, and the height was 4 meters. And they got 9.8. And I'm sure, well, if you've taken physics before, or if you take physics in the future, you'll see that the normal measurement for gravity is 9.8. I think it's 9.81 something something something. But this is what they typically use, 9.8. All right. So now we want to find out what is the gravitational potential energy of a 65 kilogram skateboarder. Okay, so he's on the same half pipe. So you're going to plug in. So we know that the G is 9.8. We know he's 65 grams, and we know the height is 4 still. So we multiply all that out, and we get 2548. So the second skateboarder has a potential energy of 2548 joules. All right, let's go on to the guided. It says, how much potential energy would a 41 kilogram diver have standing on a 10 meter diving platform? So we'll write the formula out again, potential energy. And we're not going to put G, we're going to go ahead and put that value in. So it's 9.8 because it's our constant value of M times height. And we are given, the weight, and we're given the mass, and we're given the height. So let's include that. So 41 grams, and the height is 10 meters. And when we evaluate that, we should get 4,018 joules. Okay, so the potential energy for that diver is 4,018 joules. All right, so here we have reasoning. It says, an 8 kilogram diver stands on a 6 meter diving board. At what height should a 40 kilogram diver stand to have equal potential energy? Do you need to find potential energy of either diver to solve this? Explain. So let's write down what we have. We know, so we have potential energy of one diver. So let's say diver 1 is, we have 9.8, and we have that he is at a height of 80. His mass is 80 and his height is 60. And we know that the potential energy of the second one, which should be equal, again, we have 9.8. We know that his weight is 40, and we're looking for his height. So since these two things are equal, we can set those two things equal to each other. So let me erase what I have up here. So we know that these two potential energies, we want them to be equal. So we can set these two equations equal to each other. So we get 9.8 times 80 times 6 equals 9.8 times 40 times H. Now, we really don't even need the 9.8 because they're the same on both sides. If we divide both sides by 9.8, they both go away. So I'm going to go ahead and just cross those 9.8s out. We don't need those. And so now if I multiply, I get 480 equals 40H. Divide both sides by 40. and I get H is equal to 12 meters. So the height that the 40 kilogram diver should stand at is 12 meters in order to have the same potential energy. Now, did we need to know the potential energy of either divers to solve this equation? No, we didn't need to know the potential energy of either diver. So we used the fact that the potential energies were equal. Can we find the potential energy? Certainly. But do we need it? We do not need it. I hope this helps.